But each module is made from thousands and thousands of components. And the monumental task of gathering them starts here at their massive parts warehouse.
On average, with my pedometer, I average about 8 miles a day on an average day, but if we have lots and lots of issues, my best is just under 16 miles in a day. Lots and lots of shoe leather used.
Kevin Carr's job is to make sure every engine part is delivered to the assembly line on time.
I do know the guys around here say, you know, you just give me a part number, show me a box, and I can tell you what it is and where it goes. Everything's footprinted, ready for the guys. It's a bit like a sweet shop for them. They can pick and choose what they want. We supply the very first nut, bolt or washer that they fit, right up to the very last little bit of plastic that we put on the engine before it goes out the door to the customer. So that could be anything up to 30,000, 40,000 parts, depending on which engine it is.
It's Kev who kicks off every new engine build. 2 days before the assembly begins, he triggers the dispatch of tens of thousands of parts from the warehouse.
So now it's 8 o'clock.
Have we got all the bits there for it?
Yes.
Got all the paperwork?
Yes.
Yeah, so we're all ready to go then. OK, thanks very much, Noel. Looking at the boxes, you wouldn't know, but just looking at the odds and sods that are lying on the floor, there's nothing under £1,000. You've got the engine control management unit, roughly £750,000 worth in that box, just sitting there on a pallet. Anything up to £200 million worth of stock on the shelf. We have roughly 5 engines worth of stock of anything.
Some of the components that make this engine what it is were designed and built by some of Britain's most skilled and innovative engineers at Rolls Royce. Nestling in the Lancashire Hills, 100 miles north of Derby, Barn Oldswick is where the first ever jet engines were developed by Sir Frank Whittle. And today this small community still plays a very special part in the building of every Trent engine. Raw materials arrive at the factory every day. Solid sheets of high-grade titanium. They're destined to become one of the components that make Rolls Royce Trent engines truly unique.
When you walk onto a plane, you look into the engine, that's the fan blade, and that's what we make here.
Mike Wallace's job is to transform the raw metal into high-performance fan blades.
The fan blade delivers 75% of the engine's thrust. It shifts about 1.2 tonnes of air per second, and the loading on the blade is something like 90 tonnes centrifugal load when it's at full throttle.
That's like hanging 13 double-decker buses off each of the 20 blades. The enormous fan is what distinguishes a modern jumbo engine from older turbojets. They didn't have a fan at the front and relied entirely on the jet exhaust to thrust the plane forwards. Faster than a propeller, but inefficient and very noisy. But in a turbofan, like a Trent engine, the energy of the exhaust is harvested to turn the massive fan blades at the front, which in turn push huge amounts of cold air quietly around the sides of the engine. And that's what thrusts the plane forwards. The Trent fan blades are unique.
So, which section is this?
And it's all down to their design.
The original blades used to be solid, but in order to get better performance, take weight out of the engine, it was designed to be hollow, and our manufacturing processes, which is unique, has actually enabled us to make that and advance the technology within Rolls-Royce.
Every single fan blade is worth as much as an average family car. For each blade, 3 sheets of metal are bonded together to make a solid titanium sandwich. It's a process so secret it can't be shown on television. The unique process begins when the titanium layers are bonded together in a secret pattern. Then the whole blade is inflated like a balloon, pulling and stretching the inner layer across the cavity, like cheese between slices of pizza, leaving a super light, super strong internal structure. But before it can be inflated, the flat titanium sandwich has to be heated and twisted into shape. Then it's ready for the most critical stage of the process, inflation.
We've used an inert gas. We can't have it reacting with the titanium at temperature. It's a high pressure inside to inflate it to the level of accuracy we need.
A heat-resistant tube connects the blade to a high-pressure gas supply. But the gas alone won't be enough to inflate the blade. The whole assembly also has to be loaded into a furnace at a secret, critical temperature. A single speck of dust could cause a lot of damage. And John doesn't get much time to prepare.
It gets very hot. After about 30 seconds you've got to come away. You can't stand there too long at all. If you do, you just start burning, all your gloves, fingers, everything.
It takes 4.5 hours for the gas to slowly inflate the blade to its precise aerofoil shape. Despite the precision of the engineering, no two finished blades are exactly alike. And with 20 in each fan, it will only spin smoothly if the blades are perfectly balanced. So every one is precisely measured and weighed, then rung like a bell.
Each blade has a different mass and different frequency, and we use that data to select where those blades are going to be positioned within the disc. So when we go to engine build, they're located and selected in those exact locations.
This is the attention to detail that ensures every Trent engine is as safe and efficient as it can be. And with up to 150 blades leaving the factory every week, it's also the challenge that keeps Mike going.
For me, it's exciting. After 27 years working on fan blade, it's still exciting. There's still a lot more to do.
Rolls Royce is a global company. Some parts of the engine are made and assembled at factories abroad. Getting them to the UK is Kath Taylor's job.
This is the turbines purchasing department, where we source parts from all over the world, and my role in particular is to source the modules from mainland Europe. We're talking probably at the moment about 10 modules a week. Very occasionally we're affected by the weather or the ferries, but the bulk of the modules do arrive on time.
It may be a global company, but the biggest single module is manufactured at another of Rolls-Royce's specialist factories just 50 miles down the M1. Mark Reed is in charge of building the massive protective case that shields every engine's fan blades.
The fan case's primary function is to guide the air through to the main core of the engine and to provide a containment system in the event of a blade off. When the forging's originally constructed, it weighs 5 metric tons in weight, and then when it's finally finished machined, it weighs roughly 500 kilos. So we have to take a large amount of material off, and we have to machine it down to some very fine tolerances. Typical wall thicknesses can be around 2.5 millimetres. There's a number of different processes that take place, typically around 40. A component can spend up to 90 hours in the machine. So we put it on at the beginning of the week and we take it off at the end.
And nothing goes to waste. every sliver of precious material is collected and recycled to make more components.